All right, good afternoon, everyone, and a warm welcome to all of you joining us for today's webinar. Do you know your pig's whole story? Understanding pig behavior for successful swine production. My name is Romy Timmer, and I'm working in the business department of Serket, and I'm thrilled to be your co-host for this exploration into the world of swine behavior and its impact on successful production. Today, we are privileged to have two expert speakers from Serket with us, who will bring knowledge to our virtual stage. First up is Eneko Santa, our lead animal scientist. Eneko specializes in animal behavior and its seamless integration with digital systems. Her extensive expertise and dedication have been instrumental in driving Serket's research and projects in the field of animal science to new heights. And joining Eneko is Devanshu Arya, our AI engineer for Serket, who holds a PhD in AI from the University of Amsterdam. Devanshu has been a pioneer in the field since 2017, contributing significantly to the intersection of AI and animal science. We're in for something special today, as we learn both from Devanshu and Eneko. But before we do that, I would like to share two eye-opening statistics according to research that you should keep in mind. First up is, in the United States alone, the swine industry experiences staggering losses with an estimate of 0.8 billion annually attributed to heat stress. Acute heat stress can lead to drastic reduction in feed intake, ranging from 25% to 50% of normal levels, especially affecting growth finishing pigs. And second, porcine epidemic diarrhea virus contributes to losses amounting to 50 million annually, further increasing financial strains. And lastly, allow me to bring up a few interesting questions. Like, have you ever considered the true cost of out-of-feed events in swine production? We have researched that not only do these events add a full day to the time to slaughter, but they can also lead to health issues like ochres. And the estimated cost of out-of-feed events is around $2.50 per pig per event. How do you recognize signs of an out-of-feed event in the barns, especially in the afternoon or at the end of the workday? And when it comes to post-weaning diarrhea in the nursery, what if I told you it's possible to predict and prevent this through behavior monitoring? Interesting, isn't it? Throughout this webinar, we will explore proactive approaches and practical solutions to address these challenges head-on. With that being said, on today's agenda, we go down the path of swine behavior monitoring, give a live product demonstration, and we will also end the webinar with a Q&A session. So please feel free to write down your questions in the chat during the presentation or after. And thank you for your patience. Now I will give the stage to Eneko.
Thank you, Romy. Also, a warm welcome for everyone who joined today. Let's get started. The master's eye makes the animals fat, as the saying goes. Pig keeping hardly changed during the centuries. Still, some decades ago, it was normal that farmers spent most of their time among the animals. They knew them individually and fulfilled the animals' individual needs. Although everything has changed in the 20th century, when the age of intensive pig farming came. And today, they neither have the time nor the energy to get to know thousands of animals individually. The need to observe the movement and behavior of animals appeared long ago. In 1878, Edward Muybridge took a series of photos, which was the first moving image, called the horse in motion. It was a series of 6 cabinet cards that revealed the order of the galloping horse's legs. This is the first time to use technology to know more about animals. Cameras were only used to monitor farm animals in the 1990s. At that time, research was started that tried to predict the performance parameters by analyzing video recordings. And how do we use behavior observation today? What behaviors could be monitored? Basically, we can monitor anything. Of course, there are many ways and technologies to monitor animal behavior. The most common methods used for behavior monitoring are visible on this table. There might be limitations due to the hardware we use to know more about pigs. For example, microphones are widely used to uncover respiratory issues, but we can't use them for activity detection. Regarding small ear tags and array of sensors, the farmer might catch some basic behaviors, although it's not possible to check remotely what the animals are actually doing. These problems don't arise with the installation of cameras. Cameras can record all the behaviors as humans can observe. As 80% of the problems are visual at the farm, problems would be easily revealed by the analyzing capability of computer vision. Furthermore, it's also possible to check the live videos from the pens when the farmer is not on site. Basically, it's having trained eyes on the farm without human presence. And let me introduce Serket. The company was founded by Christoph Nadi in 2016. Our headquarters is in the Netherlands, and we also have a local office in Hungary. Throughout the years, Serket won multiple awards for its innovative solution. In 2022, we established a partnership with Datamars. How does our software work? Standard security cameras are installed above the pens. It enables 24/7 continuous real-time monitoring. The videos are transferred to a server where an algorithm supported by artificial intelligence analyzes the videos. If an abnormality happens, such as pigs are drinking too much in a pen or moving less than usual, then an alert is sent to the farmer via the platform and the mobile app, thereby speeding up the solution of the problem. And let me show you some use cases and current results. Serket proceeds to reach up to 95% accuracy on group-level behavior monitoring in case of basic behaviors like eating, drinking, moving, and inactivity. 24/7 behavior monitoring does not only boost the general farm efficiency, but also a great tool to solve specific issues like heat stress. The capability of detecting heat stress has been validated with a minimum 80% of accuracy using computer vision along with environmental sensors. Testing the effectiveness of experimental feed via group-level behavior analysis is also a common use case requested by feed companies. And last but not least, Serket also offers a standalone counting product. Our counting software can register the number of animals in the pens and also can count them while walking down on a corridor for transportation, for example. And now I will give the stage to my colleague Devanshu, who will reveal what is behind Serket's AI-powered solution.
Hey, hello everyone, and thanks Romeo and Enrico for the introduction. I'll be briefly explaining the challenges associated with building a fully livestock behavior monitoring system and how our AI models can be integrated to overcome some of them. Broadly speaking, the entire flow can be divided into these 4 stages, which includes data acquisition and annotation, training AI models with these data, defining and detecting behavioral patterns, and finally deploying them to edge devices. At Serket, we acquire data from indoor farms using security cameras mounted on the ceiling. Some of the sample videos are available here for viewing. Developing an inference pipeline from this data presents numerous challenges, including variations in image quality, lighting conditions, camera coverage, to name a few. Additionally, there are significant limitations regarding processing power and memory constraints of these cameras. We'll provide a brief overview of different AI models that can be trained with such data and the potential problems in using them for our specific problem of behavior monitoring. So the simplest learning objective involves identifying each pig individually and pinpointing their positions, a process known as bounding box prediction. This is achieved through object detection, wherein the model is trained to recognize each pig and ascertain their specific locations. However, for the use in indoor farms, this technique falls short in terms of accuracy because it tends to include background elements, leading to bounding boxes that overlap and fail to accurately represent the size and shape of each pig, which is quite important in our case. Addressing these issues, the predominant and widely available strategy in the field of AI has been to predict segmentation masks, which involve predicting whether each pixel in an image belongs to a specific pig, as can be seen from the video. This technique significantly improves the ability to track each animal's precise location and shape by delineating their boundaries. Despite its advantages, though, this method does not provide information on the orientation of a pig, which is valuable to recognize any action of the pig or identify crucial body parts like ear, head, and tail. Additionally, it demands substantial data storage capacity to store the complete mask for each and every pig in each pen. So at Circuit, our AI-based solution utilizes precise key point estimation. The effectiveness of the method is demonstrated in the video here. Our model is designed to identify 18 specific key points for each pig, including areas such as the mouth, tail, head, lower back, etc. This approach enables the model to accurately map the anatomy of each pig at real time, which only requires the storage of 18 key points per pig, thereby significantly reducing the data storage needs and at the same time increasing the usability of AI models for behavior recognition. Using this as our foundational model, we are poised to address practical use cases, enhancing our understanding of pig behavior and health. This includes action recognition to observe eating and drinking patterns, movement monitoring, and aggression detection. Additionally, the model can further be used to facilitate weight estimation, counting, and individual pig tracking. Collectively, these capabilities offer a comprehensive solution for a detailed insight into each pig's behavior and well-being, thereby telling the complete story of every pig in the farm.
Thank you, Eniko and Devanshu, for presenting this interesting topic. Now that you have provided us with valuable information about computer vision in the swine industry, we are curious to know what this would look like in practice. And therefore, Eniko will show us a live demonstration of Serket's platform today.
Yeah, thank you for the introduction again, Romy. So in the next section, I will give a quick walkthrough about Serket's livestock management platform called PigGuard. And today I will highlight the uniqueness of Serket's product, which is the computer vision-based feature set. Of course, we provide traditional, conventional livestock management features as well. And if you are interested, we are way more than happy to guide you through all of that as well. So I will start with the welcome board, what you can see here, the dashboard, which contains the most important information for the user, such as the number of animals or cameras which have been added to this environment. We can see a summary graph about daily average activities on the farm, and can be also informed about mortalities and keep an eye on active rotations. The whole platform was designed in a way to be the digital representation of the farm, which means under one organization, like under one company, We can create multiple farms, and in the farms, we can create the houses, the stables, and the pens, and connect the cameras to the pens. So today, I will show you an active rotation. We can manage the animals here under the rotations page, and the active rotation means that the animals are inside the pens, they are growing, so it's possible to provide continuous real-time behavior monitoring. After they leave the pens, either they are sold or they will go to the slaughterhouse, we close the rotation and all the data will be saved in the completed rotations. So let's see an active rotation. So after opening an active rotation, here we can see the list of pens which have been added to this environment. And all of these pens will have a separate behavior analysis page. So let's see this pen 5 as an example today. For every pen, it's possible to watch the live stream with this playing live broadcast button. And after some seconds, we can see what the pigs are actually doing in real time. Unfortunately, they are not very active today. This video also represents the most ideal camera angle. Usually we work with a 1 camera per 1 pen setup. Of course, it can vary depending on the farm infrastructure and layout. Here we can see all the pigs. No pigs can hide, so we can identify and track them continuously. We can also track their eating and drinking activities. So here on the top left corner, you can see this yellow bucket. This is the feeder and drinker for this environment. Below the video, we can see the activity graphs. Currently, Serket is able to provide and monitor 4 different activities on group level, namely drinking, eating, inactivity, and moving activities. We provide continuous real-time monitoring 24/7 on group level, which means we have an aggregated data point for every minute, which shows an aggregated data about the number of events for each activity. So definitely the drinking activity graph presents the pigs which are drinking. The eating activity graph presents the pigs which are eating from the feeder. The inactivity graph shows us the pigs which are doing nothing particular, like laying, sleeping, or sitting, so basically just being inactive. And the moving activity presents when the pigs are doing active movements, like walking or running. And as I am talking, you might see that the graphs are changing. It's due to the real-time monitoring, as after every minute, the algorithm supported by artificial intelligence is adding a new aggregated data point for all the graphs. Currently, we can see the data from the past 2 hours, but of course, it's possible to review the historical data from the past day, past weeks, or in a customized period. So, for example, if we are monitoring finishing pigs, then we could even check the data from the past 3 months. All the data could be downloaded throughout the rotation and, of course, after the rotation. We can also group the activities here with this Group Activities button. And it enables the user to reveal the connections between the behaviors. So, for example, if we can see a peak in the moving activity, then we can compare it with the other activities and movements around the same period. Usually at this time, the question comes up, what happens if an abnormality happens? What if something is going bad or going very well on the farm? What's like a normal and abnormal pattern for each pen? And for this reason, we created the alert system, which can be found here at the bottom. It's called Pen Alerts, which can identify the changes in the behavior before the problem gets out of control. And here you can see some sample example alerts. Of course, unlimited number of alerts could be added to an environment. But today I will show you an alert for heat stress, which we validated not long ago. So you can see how we can create an alert. All of the alerts are based on an activity condition. Any of the 4 activities could be selected. For heat stress, now we are using the number of inactive animals. Then we can give a threshold. So this first section could be interpreted in a way that if the number of inactive animals is higher than 65%, then the alert will be activated. We can apply an alert only for one pen or for the entire farm. Usually heat stress will affect more pens simultaneously, so we recommend to apply it for the entire farm. It's also possible to connect external devices, such as environmental sensors like temperature, humidity, CO2, ammonia, or any external devices like smart feeders or smart scales, which can communicate via API. And then with the support of API, we can connect their data to our system, and we can create these complex alerts and give more meaningful insights. For this environment, now I have a temperature sensor connected, so I can also add a sensor condition. If the temperature is higher than 24 degrees, while I have a high number of inactive animals during a daytime period, then the alert will be activated and I will receive a notification. Here I specify the alert range for a daytime period from 9 to 6 p.m. But of course, it depends on the location of the farm as well. Based on the notification list, multiple persons could be selected, which means the notification will be sent to multiple persons at the same time, which enables them that someone can go there and intervene quickly and check on the pigs. As I mentioned, this is an alert specifically created for heat stress detection. And below that, we can also add a short description, which can help the users to decide what to do after they arrive to the pen. Usually for heat stress, it's checking the ventilation and the drinking system, but here this column could be customized as well. And how can we receive the notifications? There are 3 ways. Obviously, we can receive them here in the platform under the notifications widget. We can receive them via email, and we can receive them via Serket's mobile app as a push-up notification. And the mobile app is available for Android and iOS as well. And as you can see here on the right side, you can easily turn on and off the alerts. For example, heat stress alert is usually deactivated in the winter period. We can also add notes for the pens just to remind the other users what they should possibly not be aware of. And here in the middle, I just jumped over an interesting bar graph, which is showing the daily average activities from the past days. The graphs before that showing the activities separately and concentrating on the real-time data. Of course, there is the possibility to check on the historical data as well. But here is this separate aggregated graph. We can follow the different ratios of activities from the past days, which could be also used for creating alerts. For example, if we can see that drinking activity just started to increase from one day to another, and for example, we are just monitoring the freshly weaned piglets, then it will be a very good sign that in the next 1-2 days, there is a high chance for a diarrhea outbreak. There is one more thing I haven't mentioned here and could be connected to activities as well. So I will just go back here to the pens list. And here we have a short menu for each pen. As you can see, we provide many different features which are not related to the cameras, like recording mortality, updating the weights manually, or like selling the animals along with treatment and feeding plans here in the header, but we have this comparison tool, which is really interesting because here we can select 2 different pens from the farm. We can even watch the videos if we would like. And below the videos, here what the system does is to overlay the 2 activity graphs of the 2 pens in the same environment. I will just zoom in a bit so you might see it better how it looks like. So currently, I am comparing the eating activity graphs of pen 5 and pen 6 in the past hours. And again, any of the 4 monitored activities could be selected, and we can also specify the time range what we would like to compare. It's a really useful tool because it enables the farmers, farm workers to check on the pigs, check on the performance of the pigs while the rotation is still ongoing, and make some changes in the settings, changes in feed, changes in procedures while the animals are in. So there is a higher chance that their performance will improve until the end of the rotation. As I mentioned, we have a bunch of other features connected to livestock management, such as creating livestock reports or counting the pigs on the corridor as well, I mentioned. This is the end of the platform demonstration. And now I will just go back to our previous presentation. Just to summarize, the essence of using such a livestock management platform. Yes. So what actionable insights could be gained from a livestock monitoring system? This question might come up in the audience while I was presenting the product. So first of all, early detection of patterns, behavior patterns that might indicate the onset of a disease outbreak. As I mentioned, the diarrhea example during the presentation, and we could also recommend some preventive measurements to mitigate the spread of these diseases. Then there is the scenario of abnormal feeding patterns and feeding system malfunctions, which might be connected in the life of a farm. The changes in feeding patterns that may indicate issues either with sickness or a malfunction with a feeding equipment. Just think about when a feeder is broken or the pipe is stuck and the pigs just can't get the feed in time. Then here we have more complex behavior detection, such as aggression, air, and tail biting. And as my colleague Devanshu already mentioned, the key point estimation model ensures us to be able to detect these anomalies as well in the pens. Growth and weight monitoring is also an interesting issue. And I would like to highlight with these standard security cameras Serket is mainly using, it's not only possible to monitor the behavior of the animals or to count the number of animals in the pen, but it's also possible to measure and estimate the weight of the animals with the same camera. And last but not least, changes in the normal behavior pattern, such as an increased or decreased activity, and monitoring the daily activity budget of the individual animals and the whole group of animals in the pen is essential to know more about the well-being of the pigs and improve just to give a good environment. It was a pleasure to share our knowledge about swine behavior monitoring with you today. Thank you for your attention.
Yes, thank you, Anneke and Devanshu. And summarizing from today's webinar, we could learn why monitoring pig behavior is a proactive and essential aspect of responsible pig farming. So with the installation of cameras and computer vision, pig farmers can provide trained eyes in the stables without the human presence. So Serket's livestock management platform named Pigguard fits this role. The uniqueness of the platform is the 24/7 real-time behavior analysis supported by AI. And the AI model is based on key point estimation, which enables to monitor large variation of behaviors with a high accuracy. And hopefully, yeah, you got more inspired by this webinar. And if you are interested in getting computer vision being implemented on your farm or research farm, please feel free to scan the QR code and we will discuss your priorities. And with that being said, I would like to go, I would like to start the Q&A session. I see that we already have one question from Jan. What light intensity is needed for good monitoring? I think, Anneke, can you answer this question?
Yeah, sure. It's a great question. I would refer back to Devanshu's presentation when he just showcased the different environments from different lighting conditions from the same farm. So in a nutshell, we can work with various lighting conditions. We can also analyze night videos with infrared cameras, and I will just pass the question to Devanshu as he can add more technical details.
Yeah, thanks, Eniko. Yeah, in terms of lightning, we also tested our model for using infrared cameras, and we can get in fact good enough results that we get with normal day lighting as well. So if there is an infrared camera, then we can definitely have with a night vision, we can have the same accuracy as in the daylight. But obviously, I can't tell the exact lux if you're looking at, but that's what we tested our model on infrared cameras, and it works totally fine. Yeah.
We have another question. Do you use one camera per pen, and how many cameras are needed to support a farm with 10K livestock in the fattening stage? Who would like to answer this question?
I can go ahead with the first part. So we ideally we would like to use one camera per pen, but we also use one camera for multiple pens as well, as long as the pics are visible and the coverage of the camera is enough to view all the pics. Obviously, with if the number of pics goes higher and higher, then the inference rate drops as well. The second part is how many cameras we need for 10K livestock. It's difficult to tell. It will be based on the infrastructure and the construction of the farm as well. Eniko, if you have any information on this.
Yes, it really depends on the stocking density of the pens, on the size of the pens, and like the pen infrastructure. We can work with many different setups. So usually the most common commercial setups are not an issue for an algorithm to identify the peaks. But as all farms are different, of course, we work with all the farms individually just to find the most optimal camera angle just to cover the whole pen with one camera, as Devanshu elaborated previously.
All right, thank you. And I see another question. You showed monitoring per pen. How do you detect an individual being sick? Do you send alarms per individual?
Eniko, if you would like to answer this, because I mean, we do have some kind of anomaly detection, but you can go ahead.
I can go with the part like whether we can send alarms per individual pig. So currently what I just showcased, it's called group level behavior monitoring. which means like the alerts are also created for the group, like based on the average and the aggregated results of the whole pen. Although we have an ongoing development to further expand it to individuals as well, and just imagine it in a way that in the future we will have similar alert creation procedure for the individuals as well. So we already have one which is established and already proved on commercial farms that it's like a working solution. And now we can expand it to from group level monitoring to the individuals as well.
All right, I see some more questions. How can such cameras be integrated in the gestation barns, especially for weaned sows, to help in heat checking?
Yeah. Yes. So I would answer it in a way that we can also monitor SaaS. So not only like nursery and the finishing stage, but we also have experience in SaaS in gestation as well. And for heat checking, it's an interesting thing. I would say from a behavior side, what is really obvious and humans can also observe is the mounting activity when the pigs are jumping on each other. Just a bit explanation for those who are not working on daily on pig farms. So mounting activity could be also captured by this algorithm due to the T-pose estimation model. So technically it's possible to monitor mounting activity and then to identify these in-heat events.
All right, and how long does it take to implement this at a farm? Do you need to customize the models? And if I don't have cameras yet, is also a question.
Yeah, so the timeline and need for customization can vary significantly, obviously based on the complexity of the task, the current infrastructure, and the specific goals that you have in mind. We do customize the models with very small snippets from each pen initially, but then after that, mostly there is no need for customization. Uh, how long does it take to implement this is something, if the cameras are in place and if the data is being sent to the cloud and all the pipeline is there, then it should be live in no time, actually, if everything is in place.
Yeah, then it depends on how long does it take to find an installer. We do have connections with installers. Also, regarding your question about what if you don't have cameras, that's not a problem at all. We have good connections with Hikvision, so we can help facilitate that. Even though we are a software provider, we can help facilitate with the hardware. And then another question, do we need to have internet? Is there a large capacity needed for this? Or you run the solution with a computer on site?
I think you would need an internet connection, and we don't. We can run on a computer on site, but we prefer, and the solution is mostly on the cloud. So and that's another step that we're taking, that we can compute everything on the edge device, that is on the camera itself in future, and we are developing that part as well. But for right now, we can also do it via cloud. So we can send all the data to the cloud and compute everything and send it back to the mobile app.
Okay, and the quality of cameras is very important. A farm had 5 cameras and all 5 were out of order within one year. How can you solve those problems? Of course, we don't know what type of cameras that they were working with, but we're working with standard security cameras, and we know that for this type of environment, they're working well. So the only thing you need to do is once a month you have to clean the lens, because this environment can of course be harsh. But that's our experiences with the farms that we had the cameras with.
Yeah, I would also add that if the farms don't have cameras and they are looking for a suggestion, we usually suggest cameras with IP66, 67 standards, which means they are water and dust proof, and they can bear this harsh environment within the pig farm. So it's also important to select like the best camera for that environment. As let's be honest, to place a hardware within the pig farm is something you need to think of about durability. And we are working with farms. They have many cameras within the pens, and the same cameras are there for many years and still working.
Yeah, and I would like to add that if it happens that in the first year, the cameras for some reason are broken, we have 3 years of warranty that we work with the cameras that we facilitate. Then another question, do you also monitor sounds or just the video images? And do we monitor temperature? Temperature normally is the best indicator of sickness.
Currently, we are working only with the video image itself without an audio recording. So what you could see in the platform, everything is based on analyzing the simple video stream. And based on our experience, we can see that monitoring the behaviors could add an extra value without monitoring the audio from the barn. For example, as behavior is more exact, we can connect it to each pen, to like each individual. We can say, as while you are monitoring the audio, then you can be sure where that sound is coming from which pen exactly. So it might be more tricky to select the exact location of the problematic animal or of the problematic pen. And to answer the second question, whether we are going to monitor the temperature by the cameras, currently most of the farms are using standard security cameras, so they are not thermal cameras. But there is also opportunity to invest in thermal cameras, which can also capture the temperature data of the animals and the individuals. And yeah, if we have temperature data, then we can also analyze that and show the deviations, and could be an indicator of sickness, basically an indicator of inflammation or fever. But there are also other problems which are not connected to temperature, but connected to behaviors. So it's also crucial not to rely on only the temperature data. And just an example, like diarrhea from the disease section, or any equipment malfunction in the pen, which is not related to animal's temperature, but could be captured by analyzing the simple video image.
All right, another question. Do you need cameras above each pen? This can result in a lot of information, probably difficult to handle for farmers.
Yeah, I can answer this. So, as I mentioned in the previous answer as well, that ideally a camera above each pen, the more the cameras, the better. But we also work with one camera per 2 pens or 3 pens as well. It all depends on the coverage of the camera, the angle at which it is being installed. And the next point that you mentioned, that this results in a lot of information, which is actually very hard, difficult to handle for farmers. And that's what we are trying to prove from our product as well, that if you want to get a fine-grained analysis of the pig for each minute, each hour, each week, then a solution from Serket and the product that we are building would be of very important to analyze and showcase all the behavior of the pigs.
Right, another question. Do you have customers already? Where, or are you in a trial stage? I can answer this. We're not in a trial stage anymore. So what we've showed today is what we have as a commercial product. Of course, we're an innovative company, so we're continuously getting new features. So for example, we have a new customer also in Brazil, also Germany and Hungary, since we are a Dutch company, but we also have an office in Hungary. So we do have some customers there as well. Yeah, I hope that answered your question. I see that were all the questions for now. Maybe, yeah, I also have another question for Devanju. So yeah, why did you switch from the bounding boxes to post estimation? Is this more complex? What is the reason?
So Romy, as mentioned in the slides as well, that there are multiple disadvantages for using bounding box, although it is lighter in some ways to train the model. But if you use a bounding box for precise monitoring of pigs, you cannot tell the orientation or the anatomy of each pig. So where the mouth is located, where the tail is located, and at what angle are they moving in, and if they are facing towards the feeder, drinker. So these kind of fine-grained information will be missed by bounding boxes, which can be easily detected from key point estimation, which is a far more harder problem to solve. As you can imagine, you need to precisely know the exact position of its head, tail, ears, and all these 18 key points. But gladly we managed to solve this, and now we have the model which can predict quite precisely the 18 key points for each and every pig.
All right, thank you. I see another question, and that is, can you monitor all pig races? Weight, size, shape, and colors. They vary a lot. Eniko?
Yes. Yes, definitely we can. Of course, our database is based on monitoring various genetics. So we are not limited to monitoring only one genetic types. We can work with globally with the different genetics, no matter the weight, the size, or like the shape. Although I think the shape is almost the same for all the genetics. But no, it doesn't really matter. As we mentioned earlier, we can monitor small piglets to like finishers, which are at the end of the finishing stage.
All right, and how big is your core developer and engineer team? So are you able to scale up to large projects with, for example, millions of units globally? Aish?
Yeah, Devanshu, I think you can
Oh yeah.
take
So
us. You are the part of the engineer team.
yeah. So we don't have a big team. We have like combinedly the AI and engineering team is around 10 to 12 people, and yeah, we with this solution we can actually scale to larger projects. uh, I don't know if millions of units, but right now we can test it and totally tell in hundred thousands of units for sure. So yeah, I mean, I hope this answers your question.
All right, and do you have yeah, proof of concept to see if this works in a particular farm? So we do. We did at several projects. We have some files actually for that, so we can send you that after this meeting if you're interested. We'll contact you. And how much does this solution cost? How do you sell it? So the pricing model for this solution is based on a subscription model, and it's actually based on different components. You have to think of like how many pens, age classes, but also the environment itself. So including fine tuning and all these components, makes out the pricing for the subscription. And licenses per camera or pick. Yeah, that's kind of how we do it. And the cameras are separately from, so the hardware is separately from our subscription model. because we see that sometimes clients already have cameras on site. I hope that answers your question. And then maybe, and also another interesting question, I see that the time is almost over. Yeah, if Annika, could you explain how how the system works to detect the diarrhea issues, since we mentioned a lot about it.
Yes, exactly. So our current method to detect diarrhea on a group level is based on detecting the deviations in drinking activity. So again, we can like make up a scenario that there is a farm and they are interested in monitoring the freshly weaned pigs. And it's really common to have post-weaning diarrhea there. So how we can monitor, or how we can even predict diarrhea issues. Scientific research is already stated that before the diarrhea issues, there is an increase in drinking activity, and 1-2 days after this increase, there is the outbreak. So what we can do is that to monitor the animals continuously, and when we can see that the drinking activity just starts increasing in the pen, then we send an alarm to the farm workers. They can go there and start the intervention. Intervention is based on the farm procedure, whether they put their acidifiers, vitamin complex, or different additives, or do another method. So it's really up to them. What we can do is a really early stage sickness detection here.
All right, thank you for explaining. And I think I will just throw in one more question, and that's for Devanshu. So what is the maximum number of pigs your system can monitor, and why?
So there is no cap on the number of pics per camera that we can monitor, as long as they are visible and they are a bit separate from each other. So right now we have also handled around 25 to 30 pics in a pen, uh, and that gives decent results. Even beyond 30 is fine as well, as long as I said, it's not too crowded and the camera can actually each pig is visible to the camera. So that's the only criteria that the algorithm requires.
Yeah, usually we do a feasibility study when talking with a client to check if everything is correct. And yeah, as Devanju mentioned, that we can see all the pigs, because that's of course important. Oh, I see another question. How can I be sure that the cost of this solution is worth it? For instance, how much does mortality rate decreases? Or how much the use of antibiotic decreases? Aniko, can you?
Yeah, sure. Yes, so how can you be sure that the cost of this solution is worth? So first of all, you need to give it a try. So we can implement it on your farm, on farms, and then you can give it a go. And then you can see how you like this solution. And of course, it depends on the use case as well, as you mentioned. What's the target of using this solution? If there is any specific problems you would like to solve by computer vision. So we have a various portfolio, as you have seen. So we can help in all the segments of pig production. And I would highly recommend to follow us on LinkedIn and visit our website, because we already have some materials there from previous either projects or set up the system on commercial farms, and then you can see the opinion of real users and also our results from these projects. So I hope then you can learn some new findings there.
Thank you. I see we still have 3 minutes left, so yeah, I would thank you again, and we look forward to continuing meaningful conversations with everyone that took the time to be present today. Have a great day, and until the next one, the session is recorded, so we will send it afterwards. Thank you so much for being here today, and looking forward to the next webinar. Thank you. Oh, I see we still have one more question. If it's fine, I see that Jan has another question.
Oh, no.
Oh, I think that was a mistake. He left the meeting. No problem.